we have given set A, and set A has elements which belong to Z plus. It means we have here only positive integers, and n is even. Set B has elements 1, 2, 3, 4, and set C has all elements belong to Z plus. So again we have positive integers, and n is odd. So first, all numbers I use for counting are positive integers. So we can write that Z plus is 1, 2, 3, 4, 5, and so on. Next, we have to, in this example, determine the intersection of sets A and B. So first, let me remind you the definition of intersection of sets A and B. In other words, in some books we have called this the product of sets A and B. So the definition of intersection of sets A and B: the set of elements which belong to both A and B. So we have X such that X belongs to A and X belongs to B. So this is our definition. So first, let me remind you even and odd number. We know that any integer, not a fraction, that can be divided exactly by 2 is even. So we can write that set A has elements 2, 4, 6, 8, 10, and so on. So any integer that can be divided exactly by 2, and in this example we have to choose only positive integers. And the B has elements 1, 2, 3, 4. So let me copy this. We have 1, 2, 3, 4. And we know that intersection of sets A and B is all elements which belong to A and to B. So we have to choose all elements which repeat in set A and in set B. So we have 2 and 2, and we have 4 and 4. So intersection of sets A and B is 2 and 4. So this is my solution.